Hello again to another Agakala Reacts, and today we'll be watching the Geography of the Ice Age from Atlas Pro. I definitely watched something else from that channel. I can't recall what it was at the moment, but yeah, definitely make a reaction to one of the videos from that channel. So let's just watch about Geography of Ice Age, because honestly, you always kind of think Ice Age, you know, like the mammoths and things like that, and obviously the movie Ice Age, the the cartoon with Sid. And I'm pretty sure because of the continental rift and things like that, the geography back then was looking totally different than it does now. So let's just get into it and let's see.
In my last video, I went over what started and ended the 5 ice ages. Briefly, at the end, I mentioned how one of these ice ages is still going on to this day and has been for the whole of human history. What I didn't get to talk about was just how different our world was beneath the ice. The planet's climate had changed, and with it, its geography. Quite simply, the world we're familiar with today was not the same world humans knew thousands of years ago. So today, I'd like to explore this frozen Earth and uncover some of the lost geography from the earliest days of human history. First off, modern humans have been around for roughly 200,000 years, meaning we've witnessed 2 severe glaciations as a species together, between them fitting the Eemian interglacial, where conditions were more or less similar to what they are today. From this, what we can see is that the climate has been in constant flux for our entire evolutionary history, making it impossible for me to make just a single map to represent it all. So instead, I'll be using this period around 25 to 20,000 years ago as an anchor point, but may diverge a couple thousand years here and there. At this time, around 8% of the planet's surface and 25% of its land was buried beneath ice sheets. For some comparison, only about 3% of the planet's surface and less than 11% of the land is underneath ice today. This difference equates to an additional 56 million cubic kilometers of ice on the planet, which ultimately comes from the ocean. What I'm trying to say is that during this time, the sea levels fell by over 130 meters below current levels, revealing far more land area across the surface of the Earth than we're familiar with today. First and foremost, however, we need to address the glaciers. Obviously, they were all much larger than they are today, but not all ice sheets were created equal. Antarctica froze over 41 million years ago, and for all of that time has maintained ice cover, even while the North Pole remained ice-free. The explanation for this is simple. It's much easier for ice to form on land than it is for it to form over water. What this means is that while the continent of Antarctica itself has stayed icy for far longer than any other place on Earth, the waters surrounding the land essentially act as a barrier for any ice trying to expand beyond this point. And therefore, the Antarctic ice sheets didn't actually see all that much growth. Where there were other lands to be found in the south, like the southern tip of the Americas, the Patagonian ice sheet reached far into the Andes Mountains, spanning all the way into modern-day Peru, showing just how vital dry land is for ice to form. Besides this, however, only smaller ice sheets were to be found in the southern hemisphere, in places like Tasmania and New Zealand. The northern hemisphere, on the other hand, is where we'll find most of the Earth's land area, which means that's also where we'll find the majority of the new ice. Before even going all the way north, the third largest ice sheet on the planet back then and today can be found over the Himalayas and Tibetan Plateau, forming at this time an island of ice surrounded entirely by cold desert. Besides this, the Laurentide ice sheet extended over most of Canada, with glaciers making it as far as the northeastern United States. Strangely enough...
Why is it this part here? Oh wait, the part here, the Alaska and stuff. Why isn't that all covered? Like you would think... Well, I would be thinking anyway, out of just the whole thing about Alaska being so north. Was it just kind of like the tilt and all that? It actually wasn't as cold back then as it is now?
It extended over most of Canada, with glaciers making it as far as the northeastern United States. Strangely enough, what remained of what's now the US is one of the only places on Earth to have received more rainfall at this time than it does now, causing several of the basins here to fill with excess water. The biggest of which was the Great Salt Lake Basin, which expanded into what's known as Lake Bonneville. Not too far away, the Pyramid Lake Basin filled in as well to become Lake Lahontan. Besides these, numerous smaller lakes increased in volume here as well. But the greatest lake in North America came about as the glaciers began to retreat. Here, meltwaters pooled against the ice, forming Lake Agassiz. The further the ice retreated, the greater this lake became until it had grown big enough to connect with the nearby Lake Ojibwe. As glaciers continued to move, the lake followed until the ice wasn't enough to contain it all, and eventually the lake drained into...
This is interesting because I was just thinking, how do those two... let's see here. How those two lakes compare in size to the Great Lakes today? But the Great Lakes are over here, and this is just massive. I wonder, is it just... I can't remember what's the distinction between the lake and the sea. Is it just sea because it's a salt water, and the lake because of the fresh water, is it? That's the only difference?
The ocean some 8,000 years ago. Today, only the deepest remnants of this once ginormous lake remain, such as Lake Winnipeg, Cedar Lake, Lake Winnipegosis, Lake Manitoba, and the Lake of the Woods. Besides North America, another important ice sheet formed over Europe, spreading from the British Isles all the way into Siberia. Depending on sea levels and the state of plate tectonics, the Strait of Gibraltar would periodically open and close, cutting off the Mediterranean from the Atlantic Ocean. Without the influx of water from the ocean, sea levels within dropped, exposing even more land and leading to a breakup of the sea into a series of lakes. The effects of this sea level drop reached as far as the Black Sea, cutting it off entirely from the Mediterranean, leading to a substantial reduction in size here as well. This, however, is where things kind of reverse. Instead of being cut off from the ocean, the bodies of water further inland, like the Caspian and Aral Sea, actually had a new source of water.
Where is this place?
Each summer, the glacial meltwaters would flood nearly all of the drainage basins here, causing the lakes to expand far beyond their modern banks. When the ice advanced far enough, it could block the Ob and Yenisei rivers, both of which normally discharge into the Arctic Ocean. Cut off from their typical outlets, the water from these and other rivers would also periodically pool, forming in the process the West Siberian lake system. At its greatest extent some 50,000 years ago, this lake reached over 880,000 square kilometers, more than twice the size of the Caspian today. This form of glacial-bounded lake likely would have been common wherever ice overstepped onto land, meaning what I've touched on is likely only a small fraction of the many lakes that could have arisen during times like these.
What would you like?
The last major glacier system we'll talk about formed around the Alps, becoming a smaller glacial island entirely surrounded by land. This is worth mentioning because the whole concept of an ice age came about as a result of observations made by scientists visiting the Alps. It was here that they first observed the deposition of large glacial boulders far beyond where modern glaciers sat, and came to the conclusion that there must have been a time in the Earth's past when the glaciers extended much further than they do currently. If we look further east, we can see the Eurasian ice sheet actually tapers off somewhere in the far reaches of Siberia, leaving most of what's now Russia's far east surprisingly free of ice. Now, the initial assumption here would be that temperatures weren't low enough to sustain continual ice growth. But if you know anything about this part of the world, you'll know that it is actually one of the coldest regions on Earth. Switching our map real quick over to average annual temperatures, we can actually see this region is clearly colder than both Northern Europe and North America. What this means is that it doesn't really make sense that glaciers did not form here. That is, until we look at the land itself. With less water in the ocean, the entire Siberian shelf sat above sea level, filling in much of the nearby Arctic Ocean to the north and pushing coastlines further east as well. By further distancing these lands from sources of water, i.e. the ocean, this region became extremely difficult for moisture to reach. This, compounded with the air's reduced ability to hold water, and together means the deep interior of Asia just never received enough snow to begin building up ice season after season. To make matters even less favorable, wind patterns at this latitude blow air towards the northeast, pushing dry continental air out over moist ocean air. Meanwhile, over here the exact opposite occurs, where moist ocean water was pushed over the land, which explains why we see ice forming off the west coast of North America but not Russia's far east. This is important because the lack of ice combined with lower sea levels led to the formation of a land bridge between North America and Asia, what's now known as Beringia. It was this land bridge that early human explorers crossed to begin populating the Americas, meaning we have this...
I don't know, for some reason, every time when I hear about that, I think there was just basically frozen over. Like, there was just so much ice, and the ice was there year-round. For some, I don't know why, because it doesn't make sense. It's just this explanation makes much more sense, obviously. But it's just, for some reason, I was just thinking it's just so much ice in there that there was just a year long. The people could just cross, you know. So obviously, the land bridge should let me know that it's not ice bridge, because it would be called ice bridge, but it was actually land bridge. But I think this is the first time when I'm kind of thinking about it, that the fact is that because there was so many glaciers and stuff, so the water was there was less water in the oceans and seas, which actually makes a lot of sense too.
Land bridge to thank for an entire chapter of human history. This, of course, wasn't the only land revealed by lowered sea levels. Further down the coast, we can see the shallow seas surrounding Japan were dry at this time too, connecting the islands to the mainland. When sea levels reached their absolute minimum, the lower parts of the Japanese peninsula would connect with Korea to create yet another massive lake in the interior of Asia. The Yellow Sea, on the other hand, was completely drained at this time, connecting the Korean peninsula not only to Japan, but to China as well.
Would you like, Millie?
And sorry, Taiwan, but during this time you too were part of mainland Asia. Even further down the coast, we'll find perhaps the greatest reclaimed lands anywhere on Earth at this time, as the shallow waters dividing the islands of West Indonesia dried up, and a contiguous landmass rose to connect Sumatra, Java, and Borneo to Southeast Asia, forming what's known as the Sundalands.
I wonder if you can see that. Where's Millie? Millie! I think she wanna get to on the desk here. So I might just get her. Millie is not. There you go. Say hello, Millie. Millie is not a lap cat. She does not like to sit in someone's lap, so I would have to hold her all the time. But she does like to sit on the desk sometimes here, and just literally just sit or lay and kind of sniff and scratch everything. So she's now here, so you might see her tail every now and then. Okay, screen capture, there you go. I lowered the thing. How's this? That's looking good, that looks good. Let's just go back to the video.
At its greatest extent, the Sunda Basin could reach as far as the Philippines, while never pushing further east than the island of Sulawesi. As a result, it's here that an important natural boundary was formed. Being an extension of Eurasia, animals moved freely between Asia and the Sundaland, populating this region with the animals typical to the continent, such as elephants, apes, tigers, rhinos, Eurasian animals. Past this line, however, only animals originating from Australia and New Guinea had access, which is why you'll find things like marsupials and monotremes over here and basically nowhere else, making what's known as the Wallace Line the natural barrier between two entire continents. The last major island to join Asia was that of Sri Lanka, which tacked itself nicely onto India. And it was only 500 years ago that this changed, when a cyclone came through and washed away the last bridge between the two lands.
500
Continuing
years.
west, we'll find the Persian Gulf entirely filled in, turning the Arabian Peninsula into, well, not a peninsula. Around the other side of Arabia, we can see that the shallowest part of the Red Sea cut the rest of it off from the Indian Ocean, turning the Red Sea into the Red Lake, while simultaneously connecting Asia to Africa in two places instead of just one. Africa, on the whole, however, was perhaps the least changed of all the Earth's landmasses, gaining a little ground here and there, but nothing huge, especially when compared to Asia. So moving on to Europe, if it wasn't under a tremendous sheet of ice, you'd be able to see that ocean levels dropped far enough to drain the Celtic, North, and Baltic seas, exposing the lands of Doggerland and connecting Britain, Ireland, and Scandinavia to the rest of Europe, while even creating a few new islands between expanded Europe and Iceland. Even further north, we can see a huge area of land would have been exposed, filling in the Barents and Kara seas. Though all this new land really did was make it easier for ice to come in and cover it all up. North America has a very similar story actually, where under the ice, virtually all of the Canadian islands became fully connected to North America again, even going as far as Greenland. Besides these expansions hidden under the ice, however, North and Central America weren't changed all that much. We'll find the most notable differences by looking at the Caribbean, actually, where we'll see the Florida Peninsula was about 2 to 3 times bigger than it is now, though all of the islands throughout the Caribbean grew in size as well, with Cuba nearly connecting to the extended Yucatan Peninsula, and Nicaragua reaching out to nearly grab Jamaica. The biggest visible change to the American landmass, however, and really the only big change to happen to South America, came with the draining of the Argentine Sea, which added over 1.3 million square kilometers of incredibly flat land to the continent. Though, to be honest, most of this would have been uninhabitable tundra for the most part. The last big change to the continents comes by looking at Australia and New Guinea. Today, we can see only the thin and shallow Torres Strait separates the landmasses, but I'm sure at this point you can guess what's coming. Lowered sea levels closed this gap and connected the two lands into a single continent, while also managing to absorb the island of Tasmania to the south. This continent, given the name Sahul, would have measured nearly 12 million square kilometers, making it roughly equal in size to modern-day Antarctica. Besides those small glaciers found in Tasmania I mentioned earlier, Sahul would have been the largest ice-free landmass on the planet, and therefore the landscape here was largely unaffected by the Ice Age. Beyond the continents, all of the Earth's islands were also changed considerably by the lowered sea levels, but I can't actually go through every single island because there are just too many. So an honorable mention definitely goes to the islands of New Zealand for, at the very least, trying their very hardest to become a continent. While they did manage to unite themselves into a single island, sea levels never dipped low enough for the entire Zealandia shelf to be exposed. So what the planet was left with was a mega New Zealand, measuring roughly 520,000 square kilometers, making it the second largest island on Earth at the time, as many of the larger islands today weren't exactly islands back then. The title of largest island, if you're curious, would have gone to Madagascar, which, while only around 580,000 square kilometers today, would have reached a size of over 700,000 square kilometers back then. Now, beyond all of the glaciers, lakes, islands, and continental shelves, the surface of the Earth was changed in one last considerable way, and that's in terms of its natural environment, or in other words, its biogeography. This, however, could fill a video of its own, so if you'd like to see how nature reacted to all of these shifting conditions, let me know in the comments. Okay, it's at this point in my videos that I usually ask people to help support me over on Patreon, but considering the worldwide pandemic that's happening right now, it kind of feels wrong to ask people for money while my revenue has largely been unaffected by this. So to everyone who continues to support me, thank you so much. But also please don't hesitate to stop your commitment if this situation has affected you. Other than that, make sure to watch my last video if you haven't already to learn what caused this and other ice ages in the first place. Stay inside, wash your hands, thanks, and goodbye.
That was a very considerate of the man to actually mention, saying the fact that if your financial situation was changed because of the COVID pandemic lockdowns, that was April 2020, so that was a very considerate of him to say it, to just stop considering it, because he's okay. That was nice. And the video was absolutely very good. It definitely explained a few things to me, because like I said, I don't know why, I don't know why I was thinking that where the Bering Strait is now, that I always hear the land bridge. I don't know why I was thinking it's just ice. Or it probably was covered. Maybe it was covered with ice. Maybe it was, I don't know. For some reason I was thinking that it's more like a just frozen stuff and not just, because I never really took into consideration that where they are, the glaciers and the water in glaciers have to come from somewhere, and there is no, and our water isn't like constantly be making. It's a closed circle, isn't it? Because it evaporates, it rains down, it goes into the ground, evaporates, rains down, you know, makes clouds, rains down, and it's constantly. So basically we are on a finite amount. Is it finite the right word? I don't know. Finite amount of the water. So basically, if there were so many glaciers, that water must have come from somewhere. So obviously that must have come from lakes and waters and oceans and seas. So that definitely taught me new things about Ice Age. So that was very good, very well done as well. That was a great video. Thank you very much for watching, and I see you tomorrow. Bye! Really, you gonna say bye? No, she's not. Bye!